In this lesson, I'll show you how to write a Taylor series for a function. This is question number 1. The question reads, write 4 terms of a Taylor series for f at x is equal to ln x expanded about a is equal to 1. To do this effectively, we'll need to use the following formula, and this is very similar to the Maclaurin series, except that we have a factor of x minus a, and a is not 0, whereas it was in the Maclaurin series. Our function is ln x. So let's start with the first term. We have f at our a value, which is 1, is equal to ln at 1 is equal to 0. So our first term will be f at x is equal to 0. Let's move on to our second term. For our second term, we have to find the derivative of ln x. So f prime at x is equal to 1 over x. And we do have a video about this proof, where we go from ln x is equal to 1 over x as its derivative. We will evaluate this at a, which is equal to 1. If I evaluate this at a is equal to 1, I end up with 1 over 1. So we have plus 1 over 1, which is equal to 1, times x minus 1. That's our second term in the series. Let's move on to our second derivative. For the third term, we have f double prime at x is equal to, taking the derivative of 1 over x, what we do is write it as x to the power of negative 1, and we use the power rule. The power rule says that we take this negative 1, write it as a factor, and we subtract this from 1, we end up with negative 2. Therefore, negative 1 over x to the power of 2 is our derivative, and we evaluate this when x is equal to 1. Putting 1 into here, we get negative 1. So we have plus negative 1 over 2 factorial, which is 2, times x plus 1, which will become minus 1 to the power of 2. That is the third term in our series. Finally, moving on to our fourth term. For our fourth term, we need to find the third derivative. So the third derivative, denoted as f triple prime x is equal to, and I'll write this as negative x to the power of negative 2. I'll take this negative 2 and write it as a factor, so negative 1 times negative 2, x to the power of 1 minus negative 2 is negative 3. This gives us 2 over x to the power of 3. We evaluate this function at x is equal to a, and our a value is 1. We get 2 over 1. Let's substitute 2 into our ongoing series. So we have 2 over 3 factorial, which is 6. And following the same pattern, x minus 1 raised to the power of 3. We can reduce 2 over 6 down into 1 over 3. And this is our final answer. And I'll put ellipsis just to show that this is ongoing. Now part 2 asks us to evaluate ln 0.9 using 4 terms of the Taylor series. And I'll compare this number to what we find in our calculator. Let's go ahead and do that. So for question number 2, I'll substitute into here 0.9, 0.9, and 0.9. Let's see what we get. Using our calculator, we will get bracket 0.9 minus 1 plus negative 2 over 1 times 0.9 minus 1 raised to the power of 2 plus 1 over 3 bracket 0.9 minus 1 raised to the power of 3. This gives us approximately negative 0.1053. Negative 0.1053. What if we typed in ln 0.9 into our calculator? What do we get then? 0.9. We end up with something that's almost similar. Notice the difference. We had 5, 3 repeating, but in this one we had 5, 3, 6, and so on. So the more terms that you incorporate into your series, the more accurate your answer will be. And so there you have it. That is how to write a Taylor series for a function.